So I wanted to begin this lecture talking about just chapter 11, but just section 1, 11.1. In this section here, we're going to be talking a lot about probabilities. And here are some terminology to help you get through the probability. Anytime you have an experiment that's just a controlled operation that yields a result, and like I said, we'll go more deep into in detail what all this means. Outcomes of the experiment, all the possible outcomes that can come of the experiment. That's what outcomes are. An event is just a subcollection of outcomes of the experiment. And this is what we're going to be kind of really talking about as far as probability. Basically, probability is whatever we're discussing goes in the numerator. So the number of times of the event, whatever we're talking about, goes in the numerator. And the word total is kind of what you need to write down in your notes. This is actually the number of times an experiment is being performed. So the total. Just a few examples. If I wanted to know what the probability of blood pressure reduced, blood pressure unchanged, and blood pressure increase, well, we need to know the total, which is going to be 500. So what is the probability of it being reduced? It's going to be 379 over 500 because total goes on the bottom. What we're talking about goes on top. And then you just divide it and then you get your probability as far as the decimal. So what is the probability of blood pressure unchanged? 62 over 500 and so forth. Blood pressure increase 59 over 500. So these are the answers that you will see what you need to know for my MathFS Plus when it asks for the probability. Now, equally likely outcomes, this is where we basically say that it can't be changed. Whatever the outcome is, it's completely equal as far as the outcome. Just like a coin being flipped, there's really no, unless you got a shady person that just has both two heads, but most all coins is going to be a heads and tails. In the deck of cards, there are 52 cards in the deck. Um, and I have to actually the layout of all the cards because we're going to be asked a lot of card questions in this section. So I have the layout for it just for those that don't play cards. You should know what you'll have a layout for how many cards in the deck. But anyway, the cards don't change. The cards are all equally um, distributed in far as the cards is concerned. But let's talk about a die. So for this example, if a fair die is rolled, what is the probability of us rolling a 2? Well, how many faces are on a die? It's going to be 6. So it's going to be pretty much how many of our faces have the number 2 on it? Well, it just should be 1. So the probability of us rolling a 2 is going to be 1 over 6 because there's one face that has a 2 and there's 6 possibilities as far as these outcomes. So 1 over 6. So what is the probability of just doing an even number? Well, how many even numbers are on a die? We have 2, 4, 6. If you get a die from a Monopoly game or something and look at it, there's 2, there's 4, and a 6. These are my even numbers. So there should be a 3 out of 6 chance of us getting an even number, which reduces down to 1/2. What is the probability of us rolling a number greater than 3? So look on the die again. What are all the numbers greater than 3? 4, 5, and 6. So once again, there is a 1/2 power possibility, 3 out of 6 chance that when you roll it, you'll get a number greater than 3. So what is the probability of us rolling a 7? Well, the die only goes up to 6. So there's really a 0 out of 6 times you get a 7 because there is no 7 on a die. So that's why this would be 0. And what is the probability of us getting a number less than 7? Well, like I said on the die, there are 1, 2, 3, 4, 5, 6 on a die. So what is the probability of getting us less than 7? Well, all of them. So it'll be 6 out of 6. So it'll be a 1 as far as your answer is concerned. These two here is pretty much a kind of in-depth way of looking at as far as probability of not, but it's pretty much using common sense. But anyway, if you have the probability 100% and then you have probability, well, that's going to be the probability of us not getting it. So let me kind of go through as far as showing you what it means as far as making sense as far as the not part. But here's the layout of the cards just in case you need to um, know about cards. There are 13 hearts, 13 diamonds, 13 clubs, 13 spades. Face cards are considered to be the letters, except for the ace. because the Jack, King, and Queen has a face. So these are considered to be face cards. So what is the probability of us having getting an 8 out of a deck of cards? So if I kind of go back at the deck, there are 52 cards in the deck, but look at here. I was getting an 8. We have 1, 2, 3, 4. So for this one here, it'll be 4 out of 52, which reduces down to 1/3. So again, when it's asking for the probability, the number that we're talking about, which is the 8, goes on top, and the total goes on the bottom. So the part B was, what is the probability of us not getting an 8? Well, since we already know that there are 4 cards that are an 8, well, there should be 48 cards that are not an 8. Because what does that mean? 52 minus 4 gives us 48. So if you look at all the cards in the deck, there's 48 cards that are not an 8. So that's what the not means over here. So you really don't need to do this 1 minus here. It's, like I said, it's pretty much common sense as far as saying if there are 4 8s, there should be 48. There are not 8s. So you put that over 52, reduce it, and we get 12 over 13, just like if we did the formula that I shown here. And you still get 12 over 13. So let's finish off the rest of these examples. There are 13 clubs in the deck. So what is the probability of us picking a club? Well, since there's 13 out of 52, it reduces down to 1/4. So there's actually a 1/4 chance of us picking a club out of a deck of cards. So here's where we're talking about face cards. So what is the probability of us picking a jack, a queen, or a king? Well, there are 4 jacks, 4 queens, 4 kings in the deck. So if you add them together, we get 12 out of 52, which is equal to 3, which reduces to 3 over 13. Remember, anytime you need to reduce a fraction in your calculator, type the fraction in your calculator, 12 divided by 52, hit math, enter, and it reduces it down for you to 3 over 13 for you. Now here's the tricky one. What is the probability of us getting a heart and a spade? So when we pull one card out of the deck, what is the probability of us getting a heart and a spade? Well, it has to be 0, because look in here. Look at the listing of cards. Where do you actually see a card that has the heart and a spade together? Where there's not. You're either going to have a heart or you're even going to have a spade. There is no one card that has both of those suits together. So that's why the problem down here would be 0 out of 52. There is no chance of us getting both on one card, a heart and a spade. So what is the probability of us getting a number greater than 5 and less than 9? So remember, all the numbers go up to 10, but we need to know what is the probability between 5 and 9. So what are the numbers between 5 and 9? 6, 7, and 8. There are 4 6s, 4 7s, 4 8s, which makes it 12. If you add them all together, over 52 is the total, and that gives us 3 over 13. So I'm going to stop here. I'm going to go to MyMathFest+ in section 1 and work a few problems from there so you can kind of get an understanding of or look at a couple of the viewing examples. Looking at this viewing example here, they're asking for what is the probability of us getting a store favorites rock music. So we kind of go up here and figure out which one is rock. Well, it looks like 12 is the rock, but how many, remember, the total goes on the bottom. So which one of these represent total? Well, out of 64, 12 are rock. So guess what? We're going to put 12 over 64, reduce it in our calculator, and we get 3 over 16. By all means, anytime during any of these videos, pause it just to see or prove to yourself that if you put in a calculator, hit math, and enter, you'll get it reduced to whatever you need to get to. So pause it and then resume play on any time you like to during these videos. So the second one says, what about country music? So country music has 16 over the 64. You put that in your calculator, reduce it. 16 it reduces down to 1/4. The last one talks about what is the next person entering the store orders something other than rock, classic, or country or classical music. So this one here will be 13. This is actually reduced already from 13 over 32, so you don't need to reduce that any. as far as that problem. And they got 13 over 13 by taking the 26 and taking it over 64, because the 26 just chose other than rock, country, classical. So you do 26 over 64 reduces down to 13 over 32, and it can't go any further. So this is where the final answer is. But that's for number 7. If I kind of scroll a little bit more, the same thing occurs for these examples here. Here is the total, because they kind of added it up together. So when it asks for country E, so guess what goes on top? Country E over the total of this one. So this one here, you put this 2 in your calculator, 12,464 over 151,454, and to reduce it, and then that's will be an answer for E, and so forth. Let's see if we can go over maybe one more example for this one here. Looking at this one again, when it asks for the probability, we're looking for whatever we're talking about on top. For this particular one, we're talking about white flowers over the total. Well, here they haven't given you the total. Well, I'm actually do the example one. For this one here, they actually didn't give you in the problem the total. So we have to actually figure out the total by adding 753 by 315. That's now our new total, which goes on the bottom. So what is the flowers? 753 over 1,668 as far as total plants. Reduce it, and now we get a decimal. So with some of these, you'll get a decimal. Some of these, you'll leave it as a fraction. The key thing that you need to look at is where it says round to the nearest 100 spots as needed. This is where you take that fraction and actually give me a decimal, and you don't leave it as a fraction like I did in all the other examples. Rounding to the nearest 100 spot is 2 places behind the decimal. So this is why we get 0.71. So just to kind of give you one more look at it, we have 753 divided by 1068. We hit enter. And like I said, we're not changing to a fraction or reducing it because we want to round to 2 decimal places. So this is the 10th spot, this is the 100th spot, this is a 5, that makes this go up to a 1, and this is where we have the answer of 0.71. So the rest of these problems here is pretty much all about probability. It's just, again, placing, understanding what's the total and what's what we're talking about over the total. And if we're talking about not, remember, just kind of do that 1 minus, or just use the common sense part of it. If we have this a certain amount, well, we don't have this certain amount, so we can do our subtraction like so.